Hi, 2E0TWG at your service. End-fed half-wave antennas. I'm a big fan. Do you know what it's about? Is it the same as a random wire antenna? Do you know what the difference is? Let's have a look at it. Okay, so end-fed half-wave antennas. Well, the clue is in the title, half-wave. Now, unlike random wire antennas, and the clue there is the word random, the end-fed half-wave antennas are meant to be, in terms of length, at least a half wavelength long on the lowest frequency you want to operate. So, for example, if you're looking to operate 40 meters, it should be around 66 feet long or thereabouts. For 80 meters, it'd be double that, about 132 foot. For 20 meters, you're looking at 33 feet. The advantage they have over, say, a monoband dipole is the fact they're not monoband. So with an end-fed half wave, you automatically get a resonance on a harmonic of the lowest frequency. For example, if you have a 66-foot one, which has resonance as a half wave on 40 meters, it'll also get you resonance on 20 meters as a full wave, on 15, and on 10. Similarly, the 80-meter version, the commercial ones have a little compensation coil about, I think it's something like about 2 or 3 meters from the transformer box, and I'll talk about that in a minute. But what that does is allows them to get resonance on 80, 40, 20, 15, 10, and even the walk bands as well, 17 and 12, are usually able to be brought in with the use of a tuner. And in fact, you can bring them in with the use of an internal tuner on the rig with the 40 to 10 version. But obviously it won't radiate as well. Thing is, and with the random wire antennas, they usually are fed with a 9-to-1 Unan, which you may well have heard of. It's designed to bring the impedance down to around 50 ohms. And there are magic lengths of wire you should be using with 9-to-1, so-called magic lengths. And you should avoid, for that purpose, any length that's around a half wavelength of any frequency you want to use. So, for example, you don't use a 66-foot wire with a 9-to-1 Unan, because the impedance would be so high, we're talking thousands of ohms, that a 9-to-1 won't bring it anywhere near where you want it to be. So therefore, you're looking to set or use, I should say, a length of wire that is comfortably away from a half wavelength, which hopefully the 9-to-1 Unan can bring somewhere around the 50 ohm mark, which presents an acceptable match for your radio. People who use those systems, some people have lots of success with them. Others have issues with RF in the shack. They also require a decent counterpoise, often close to the length of the wire you're using. Generally, they're hit and miss. With the end-fed half wave, it's a different system. Now remember, you're talking about half wavelengths. So therefore, the impedance, as I've said before, is going to be very high. Hence, you don't have a 9-to-1 Unan. You have a 49, a 50-to-1, sometimes a 64-to-1, depending on the system you're using. So as you can tell straight away, it has a greater mismatch to deal with. But the beauty of the system is that what you then get is resonance on the harmonic bands. Now, one thing to bear in mind is that with a half wave, you have the traditional sort of pattern of radiation where you have the current maximum in the middle of the wire. So this is the wire here, that's the middle of the wire. So it goes like that. So the peak radiation is in the middle and dies down, just like a dipole. With the when you go to a full length, so if you look, for example, if you're using the 66-foot length on 40 meters, you have the pattern I've just said like that. When you come to 20 meters, you then have a slightly different pattern. Instead of having the pattern like this, great, this isn't it? You go like that, and then like that. When you go to 15 meters, you have more nulls and lobes, and 10 is literally like that. Okay, So it is a compromise. It's not a magic thing that will give you fantastic performance on every single band. Very few antennas do. But the advantage of the end-fed half-wave is it's easy to deploy. You can do it as a sloper. If you've got a tall enough support, you can do it as a vertical. You can do it as an inverted V, an inverted L sloper, flat top if you can. It's great. If you're looking to install it permanently, then a ground system is a good idea. And lots of people try to position the transformer box within a sort of 3 to 4 feet of the ground, so you can then connect as short a wire as possible from the transformer box to the ground. But it's portable wire, it comes into its own for me. I don't have one at home. They are noisier, I find. Okay, don't shoot me. I find them noisier at home than a balanced antenna like a doublet or a dipole. They still radiate really well, but there's about another 1 or 2 S points of noise on the band, and I'm prepared to sacrifice the convenience of it for that extra, or fewer, I should say, 1 or 2 S points on my noise floor. But if you get somewhere electrically quiet, you know, near the sea, in the countryside, wherever you're going to go, they're great. And they give you so many options. Now, what I've done, I've got a 49-to-1, I believe it's a 49-to-1 transformer. Someone needs to put me right here. What I've gone and done is I've just swapped the wire that came with it. It had the 40-20-10 version with the shortened wire, the coil and the shortened wire for 40 meters. So it was only 12 meters in length, which is much shorter than the full 66-foot version for 40 meters. But that version of the end-fed half-wave gives you 40, 20 and 10. If you go online, I might put some links on the description underneath the video so you can see and look for some of these examples yourselves. But going back to my version, what I've gone and done, I thought, well, a dipole is actually easy to put up. You know, you've got one centre support, an inverted V I'm talking about now in the field. You've got one centre support, you've got the 2 wires coming down. Easy. You just tie them off and make sure the ends are high enough so people can't touch them because of the voltages. Yeah, okay. What I found sometimes, trying to replicate an inverted V, which is my favoured way of deploying an antenna of this size in the field, is that when you put the pole up and you stretch the wire, sometimes it just creates a problem. I find it can get snagged, it can pull the pole down. It's probably just me being very ham-fisted. So what I've gone and done, I'll show you in a minute, I've basically said, right, I'm going to be operating from my car, okay? And I have a drive-on plate, and I put the main 10-meter pole in the drive-on plate and part with my front passenger wheel on the plate, and the pole goes up. Okay? So I'm thinking, right, what I want to do then is put the transformer box that is fairly near to the car, so I can run as short a run as coax as possible into the rig. So what I've done, I substituted the wire that was on the original and got 67 feet of wire. And I've cut it, not in half like you would a dipole, but I've done 20 feet one side, so 20 feet one side, and then about 27 feet one side and 40 feet the other. You get the point. And I've worked out through the wonderful use of Pythagoras' theorem, and I had a headache afterwards, that if I put the feed up 8 meters, and I put the pole I was going to put the transformer on about 10 feet that way, that'll give me about somewhere in the region of about 20 odd foot of wire going down. And then it won't be a very long run of coax through the boot or the trunk of the car into the front of the car, into the rig. Okay, and it worked really well. Unfortunately, when I operated, it was about 3 or 4 weeks ago. It was a weekend evening. I was able to get out for a couple of hours because work's busy and home's busy at the moment. And yeah, it worked really well. It worked really well. So I'm not able to show you details of how it looked in the field, unfortunately, because it was pitch black. It's the winter, so that wasn't good thinking. But I will show you how it looks in terms of the centre connection and the wires. Please note, none of it's soldered. It was very much a test. So what I'm going to do next is make sure I solder those connections properly and make them waterproof. That's the next job. But it worked. The SWR on 40 was a bit high. Well, I'd say a bit high. It's about 1.5, 1.6. I didn't put it through the analyzer because I haven't got room in my QTH to put up a 67-foot wire. So the next time I'm out with it, I need to dedicate 3 or 4 hours literally to put it up, get the analyzer on it, and then trim it so that we have a good dip in the SWR within 7.1, something like that. I have a feeling it's long because the SWR did get lower towards the bottom end. It was about 1.5 at around 7 megs, about 1.7, 1.8 at 7.2. So clearly it's shifting down. So that's okay. That's the lesser of two evils. I've got too much wire. I don't mind that. Yeah, so I'm going to show you a clip of what it looks like. Just to say, you know, have a look and see what you think. Let me know. Put any comments down. And at the end, I'll just tell you quickly how it went. It was about an hour's worth of operating, and got some contacts on 20 and 40.
Okay, so here's the wire itself. That's the shorter version, the shorter wire.
Thank you.
There's the centre piece with the short green jumper, creating the join between the two legs. So we have one continuous wire. Then you have the longer wire. That's about 40 foot in length with the paracord. That gets tied off at the far end. And then you have the pole with the transformer on. That'll be about 10 feet away from the main pole. That's very solidly on there, look, as you can see. And there's the green counterpoise wire, not strictly necessary with an end-fed half wave, but it's there as a belt and braces option. And here's the transformer on the pole. As you can see, it's about a meter in length, meter in height, I should say, in an umbrella stand, as it will be, with plenty of weight on there, so that won't go anywhere. And as you can see, there's the wire, and yeah, there's the centerpiece again. That tie wrap will go over the pole and tighten down on about the 8 meter point, 8 meter in height. And there's the counterpoise.
So, how did we do? Well, on the evening itself, it went pretty well. It's out for about an hour and 20 minutes, looking at the little written log here. Made about 10 contacts, not bad. Got into America way after the grey line. Got into Pennsylvania at about 2024 UTC, which I was particularly chuffed about. And actually, I hit plenty on 20 metres. The SWR on 20 was really good, well below 1.5 for the whole band. Got into, I can't remember what this bloke was now, WA2VUY, New Jersey. That was on 40 metres, and I was at 2100. And then into Canada, into Newfoundland at 2121. And just after that, I closed down. Made a few other EU contacts as well, into Denmark, Spain, looking at the log here, Russia, Belarus, and Serbia. So it works. I think I'd like to deploy this antenna possibly as a sort of field day option. So yeah, it's all good fun. We'll see how it goes. But the antenna worked really well. I'll definitely try it again. And I hope you've enjoyed this little look at end-fed half-wave antennas. I'll put some links on the description for you to look at. And I hope you've enjoyed it. Stay tuned for more. 73 from 2E0TWG signing off. Take care.